Okay, girls. Today we will study alkanes. Preparation and properties of alkanes. Preparation and properties of alkanes. Okay. Preparation and properties of alkanes. ICS systems. Okay, girls. So in the first I will give you all the headings. Then I will discuss one by one. In preparations today we are going to discuss about decarboxylation and reduction and hydrolysis, hydrolysis, and last one is Woods reaction, Woods reaction. And coming to the properties, in properties, I'm going to discuss combustion, combustion, halogenation, or halogenation we can say even substitution, substitution, and catalytic oxidation, catalytic oxidation, and apart from catalytic oxidation we will also see slow oxidation, slow oxidation. These things we are going to study today, children. So children, for decarboxylation, okay, first preparations I will say. In decarboxylation we have to take okay, like suppose respective esters we have to take. How suppose CH3 COO Na plus soda lime. Soda lime is a combination of NaOH and CaO. When you take this CH3 and this H will combine to form CH4 and you will get Na2CO3 sodium carbonate. If you take sodium ethanoate, this is called sodium ethanoate. If you take sodium ethanoate, you will get methane. No sir, I want ethane means take C2H5COONA and same, take soda lime. What is soda lime? Mixture of NaOH and CaO. Then you will get C2H5 and H, C2H6 plus Na2CO3. No sir, I want propane means take C3H7COONA. What is this called? Sodium butanoate. Take sodium butanoate. Then you will get propane C3H8 plus Na2CO3. Like that continuously you practice up to decade, girls. Now children, then you will get that. So children, if you want methane, you took sodium ethanoate. If you want ethane, you took sodium propionate. If you want butane, propane, then you took sodium butanoate. Like that, you have to take respective esters and they have to react with soda lime. Soda lime means combination of NaOH and CaO. This is decarboxylation reaction. Okay, second one reaction. Take any alkyl halide, subject it to reduction. Reduction is addition of hydrogen. Then what you'll get? You'll get one HCl or whatever halide you take, and plus your respective alkene. Let's see some example. If you take CH3Cl and subject it to reduction in presence of a nascent hydrogen, freshly prepared hydrogen, one HCl goes out as HCl and one H and this will react to form CH4 methane. No sir, I want ethane means take C2H5Cl and subject it to reduction, then you will get HCl plus C2H5 plus H, C2H6 ethane. If you want propane, take C3H7Cl plus go for a reduction, then you got HCl plus C3H8 like that. Whatever you want respective alkyl halide, you have to take respective alkyl halide. Okay, next hydrolysis. In hydrolysis, children, only one reaction is possible for the preparation of methane. In hydrolysis, take aluminium carbide and subject it to hydrolysis. So hydrolysis means addition of water. Then you get methane plus aluminium hydroxide. Methane plus aluminium hydroxide. 4 aluminiums, put here 4. 3 carbons, put here 3. 3 fours are 12, 3 fours are 12. So put here 12 and 12 oxygens, 12 oxygen balanced. This is only one reaction possible, children. Here means you can write up to decane, but here you cannot write. And last one, Booth's reaction. Booth's reaction is also important for your intermediate. So girls, you have to take two alkyl halides, CH3Cl, CH3Cl, and put two sodium atoms in presence of dry ether, dry ether. Then this 2 NaCl will go out as 2 sodium chloride molecules plus CH3 means what? C2H6 ethane. No sir, I want next compound means take C C2H5Cl, C2H5Cl plus 2Na. Okay, girls, try it. Same, this will go out as 2NaCl, and what you'll get C4H10 butane. No, sir, I want something else. We'll say take C3H7Cl, C3H7Cl. Again, take through sodium. NaCl will go, and you'll get what, girls? C6H14, C6H14 propane. Like that, you will get. So decarboxylation, reduction, hydrolysis, Wolff's reaction is your preparations. Children, I told first three compounds remaining up to decade you practice, you become perfect. Up to decade you practice. If you want next compound, just add CH2, 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 homologous series. Keep on adding CH2 for the next. CS, if you add CH3, 2, you get C2H5Cl. You add CH2, you get C3H7Cl. You add CH2, C4H10Cl. You add CH2, next compounds you will get. Okay, children. So these are the preparations. Now coming to the properties, guys. You know, see here properties. Preparations are over successfully. They are completed. So practice. Without practice, you won't understand, children. If you practice, then you will understand where you are missing and what you are not understanding. Combustion. Combustion is heating anything in terms of air. You take any organic compound and subject it to combustion. You'll get compulsory carbon dioxide, water, and energy only. All combustion reactions are exothermic reaction because they liberate heat. If you supply more supply of oxygen, you get carbon dioxide. If you supply less oxygen, you get carbon monoxide. Okay, any organic compound, you take carbon dioxide, water, and energy only, you get that is combustion. Simple. Next, halogenation. Halogenation means listen carefully. Add chlorine to methane. What you get? One H, one Cl will go out as HCl, and what is left over? CH3Cl. Take CH3Cl and again add chlorine. One H, one Cl goes out as HCl. What is left over? CH2 one Cl2. Take CH2Cl2 again and add again chlorine. One H, one Cl goes out as Cl. You get CHCl3 chloroform. Take CHCl3 again and add chlorine. One H, one Cl will go away. You get CCl4 carbon tetrachloride. Now this gone, this gone, this gone. CH4 plus 4 chlorine molecules gives 4 HCl's plus CCl for carbon tetrachloride. This normally in books they will give this only. All this reaction is a complete reaction. Those who didn't understand this, one more compound I will say. After that you do it. Suppose C2H6 is there plus Cl2. One H, one Cl goes out as HCl. What is left over, girls? C2H5Cl. Take C2H5Cl again and add chlorine. One H, one Cl will go out, and what is left over? C2H4Cl2. Take C2H4Cl2 and add Cl2 again. One H, one Cl goes out as HCl. What is left over? C2H3Cl3. Take C2H3Cl3 and add chlorine. Okay, one H, one Cl will go out as HCl. You'll get C2H2Cl4. Take C2H2Cl4, add again chlorine. One H, one Cl goes out as HCl. You'll get C2HCl5. Take C2HCl5 again and add chlorine. One H, one Cl goes as HCl. What is left over, girls? C2Cl6. This is called hexachloroethane. Hexachloroethane. This is tetrachloromethane. This is tetrachloro. One means methane. This is hexachloroethane. Like that. So cancel, 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 cancel. First reaction is C2H5Cl. How many chlorines we used? 6 chlorines. Okay. Six chlorines we used here also. Sorry, children. First one is C2H6. No? Take C2H6 plus Cl2. How many 6 chlorines? 6 HCl's you will get plus C2Cl6. Like this, if you practice for propane, butane, pentane, you become perfect. For methane, 4 is there, so 4 reactions. For ethane, 6 hydrogens are there, so 6 reactions. For propane, 8 hydrogens, so 8 reactions will come. For butane, 10 reactions. For pentane, 12 reactions, like that it will come. You practice, you become champions in this carbon compounds lesson. You have to practice. This is halogenation and combustion. Next, catalytic oxidations. Catalytic oxidations. What is catalytic oxidation? Means take alkane and go for oxidation. If you do oxidation in presence of copper, you will get alcohols. If you do oxidation in presence of molybdenum oxide, you will get aldehydes. If you do oxidation in presence of manganese, you will get carboxylic acid. Okay, girls? So suppose it is methane. What alcohol you are expecting, girls? Methyl alcohol. What aldehyde you are expecting? Methanol. What carboxylic acid you are expecting? Methanoic acid. This in presence of copper, you should do separate. They are separate. This you will get in molybdenum oxide. This, if you use manganese, you will get this one, formic acid. No, sir, I will use C2L6. It's okay, use your wish. If you use copper, you will get ethanol. If you use molybdenum oxide, you will get ethanol, CH3CH1. If you use manganese, you'll get ethanoic acid. You know, sir, I will use propane. It's use your wish. If you use propane copper, you will get C3H7OH propanol. And here molybdenum oxide, if you use, you'll get propanol. If you use manganese, you will get C2H5 propanoic acid. Propane will give propanol, propanol, propanoic acid. Ethane will give ethanol, ethanol, ethanoic acid. Methane will give ethanol, methanol, methanoic acid. Like this. This is catalytic oxidation. And last one is slow oxidation. Okay, that's last one is slow oxidation. Slow oxidation means take alkane and oxidize in presence of alkaline KMnO4 or acidified K potassium dichromate, you will get alcohol. Take alcohol and subject it to oxidation, alkaline KMnO4 or acidified K2Cr2O7, you will get aldehyde. Take you need not take it will only convert sugar. Aldehyde on oxidation becomes in presence of they are oxidizing agents. KMnO4 and K2Cr2O7 are oxidizing agents. You will get carboxylic acids. Okay, same. Now what we did, but this is continuous. If you take methane, you will get methanol. You will get methanol. You will get methanoic acid. This you should write up and down, children, compulsory. If you take ethane, you will get ethanol. You will get ethanol. You will get ethanoic acid. If you take propanol, you'll get propanol. You'll get propanoic acid. Propanoic acid. Just add CH2, children. To this, if you add CH2, you get this. If you take butane, you'll get butanol. Butanol C3, H7, CH2 you add. Butanol, CH2 you add. Butanoic acid. This is in presence of alkaline potassium permanganate or acidified potassium dichromate, which both are oxidizing agents. Alkane becomes alcohol, alcohol becomes aldehyde, aldehyde becomes carboxylic acid. You have to practice like this up to 10. You will never forget. So four preparations, four properties: decarboxylation, reduction, hydrolysis, Wolff's reaction, and manipulations. Combustion, halogenation, catalytic oxidation, slow oxidation is properties. Do up to decade whether they ask you or not. You become perfect. And that's it. Anyone have any doubts? You can ask.